One of the curators who worked on this, so you're going to see bits of science fiction and toys and the kinds of things that I work with here as one of the curators in the space history department here at the museum. So given the opportunity to talk to you about time, I thought that I would pull some examples from the museum's collection and from some of the things that I think about in terms of space science fiction. So this is a Buck Rogers toy from 1934. There's a very similar one that you passed on your way in that's a part of our exhibit here illustrating the idea of a space plane. And in some ways it's an odd way to start this talk because Buck Rogers really didn't think that much about time in space, right? Buck Rogers started as a comic strip in a short story actually in 1928 that became a comic strip, and if you know the story, it's Anthony Rogers, this blonde hero gets knocked unconscious in an explosion in a mine and wakes up in the 25th century. So that's kind of their allusion to time. But then the future is this space age, and he kind of zooms all over space, just showing up wherever the adventures are without really any thought about how this space plane worked or what it would take to get him to those places. And so we have a lot of examples of this because with the social and cultural collection here at the museum, one of the things that I spend a lot of time thinking about is these various stories that can be told. And I think these about how people have imagined spaceflight, about how they have imagined possible futures, distant planets, and even time itself. And so this is a set of board games from Buck Rogers from 1934. And it, I think, becomes one of the objects that allows us, so you'll see right off the bat, for instance, that Buck Rogers was not exclusively in space in the very early career before the comic strips turned into comic books and radio programs and movie serials and became a very long-lived franchise. But these objects that we have here at the museum that are part of the social and cultural dimensions of spaceflight collection that I work with, I think really become very rich sources for telling these broader cultural stories about how we, humanity, have kind of imagined ourselves going out into space. And there's a very close relationship between those imaginings and the real stuff of actual spaceflight. So what I wanted to talk about today were some examples from space science fiction. And I'll say right at the outset that I'm setting aside time travel. That's just, it would be a great topic for something like this, but that's not what I'm going to do this morning. My husband always thinks that it's a bit of a narrative crutch to have time travel. I personally love time travel stories, but we're not going to do time travel stories this morning. What we're going to look at instead is some of the different ways that time has been depicted in space science fiction. And from this 1952 puzzle wrapper from a Buck Rogers puzzle, you can see that we had wonderful depictions of space stations and spacesuits, ray guns, rocket ships. But again, part of my argument is going to be that in the 1920s, 1930s, 1940s, nobody in broadly received science fiction is really thinking all that much about time and distance, although that was an idea that had been around in the actual science. And so that brings me to this gentleman and to thinking about distances in space and what that has to do with time. So this is Friedrich Bessel, who is a Prussian astronomer. I know you were hoping we would have a Prussian astronomer this morning. So Friedrich Bessel in 1838 was able to measure for the first time the distance to a star, and he did that using something called parallax. You use parallax every day to be able to see distance. It's the difference between left eye, right eye, left eye, right eye, right? You get slight difference in what you see out of each eye, and together your brain puts that together and can gauge distance. Well, as the Earth moves, Friedrich Bessel was the first person to be able to perceive a slight change in the position of a star. And using that, he was able to determine just how far away that star was. And when he published it in 1839, he was able to say with some certainty that 61 Cygni, the star he had picked out, was 66 trillion miles away, which is a very, very large number and very hard to relate to. So one of the things that he added in his publication, just as a way to make this a little more relatable, was he suggested that light takes 10.3 years to go that distance, 66 trillion miles. And in doing so, he is one of the first person to really suggest the idea of a light year. And that in fact you might use time to measure distance. And by the late 19th century, this becomes a really accepted idea in astronomy. And we're familiar with the idea of a light year as a measurable distance that light at a constant speed travels in 1 year. And in fact, I would argue it's a really intuitive concept to think about this conflation, this overlap between time and distance. On your way in this morning on your name tag, I asked you a question. How long is your commute? Not how long does it take you to get to work, how long is your commute? Who gave me time? Anybody who didn't? It gave me like 12.3 miles or some specific measure of distance. Because I asked you a distance question, and very few people answered light years. So, I'm sorry, sir. One of the worst commutes in DC. So asking you a distance question, you intuitively gave me an answer in time. We think about distance in terms of time. How far is it to the store? How far is it to school? How far is it to my job? How far is it to go visit my parents for the holidays? And so this is that overlap, which I would argue becomes a really important part of the scientific thinking about spaceflight, even before it gets into the kind of popular culture reception. So there are creative people who are trying to think about how humans with these relatively short lifespans are going to cope with the immense distances, 66 trillion miles we know in 1839, to one of the nearer stars. How are we going to cope with these immense distances? And Robert Heinlein published a story in 1941 called Universe, in which he suggested the idea of generation ships. So a massive spaceship on which people would live for generations because one human lifetime would not be enough time using kind of conventional methods to get to where you needed to go. And you can see from the cover of this, the premise of the story is that the people on the ship have been on the ship for so long they've forgotten it's a ship. They've kind of devolved to this primitive state where they worship the ship as a religion and they don't know why they're doing the things that they do to service the ship. And you also see that there have been mutants who have developed on the ship. And this is the character in the back is a character called Joe Jim Gregory, whose two heads have separate personalities. And in fact, part of the premise, I won't ruin the end here, but part of the premise of the story is that two heads in this case are actually better than one. And he has begun to figure out that they are in fact living on a spaceship and traveling through space. And he's trying then to convince the rest of the people on the ship that this is in fact the truth and not heretical. And this is an idea that is one of the first ways that people thought about with a real scientific background, and Heinlein puts it into fiction, thought about how they could conquer these immense distances and the requirement for so much time in space travel. And it's something that continues to have real resonance. So Kim Stanley Robinson, if you haven't done your holiday shopping, has a new book out, Aurora, just came out this year, reintroducing the idea from a hard science fiction background of doing a generation ship. And this was something that we saw not only in Heinlein's fiction, but it was something that was being advanced in what we call speculative nonfiction. So experts writing about ideas about what could happen in the future. And in this 1953 book, The Complete Book of Outer Space, if you can read the side, they have expert articles from Willy Ley, from Dr. Werner von Braun, from Hans Haber, Hugo Gernsback, suggesting different ways that they could conquer the immense distances and the time required to cover them in space. And what the suggestion for the long duration space flight article is that in fact they would create, and they had visualized a form of a generation ship, the hollowing out a meteorite and creating something that generations of people would be able to go on. And they in fact say that serious men of science are now working on plans that will soon be realized for something like this. And I think part of what's fun about this is when you get a close-up look at that diagram, they have really thought about all of the ways that you might move, say, 1950s suburbia into the inside of a meteorite. So we have a university and a swimming pool and a grade school and theaters, a hospital, and unfortunately so you can get just a taste of the kind of literally lower levels of this society where there is the slaughterhouse and the refrigerators and the cattle and the pork and all of the things that you would need to have a full society move into space in the midst of this generation ship in a meteorite. So these are the kinds of ideas that are being advanced by scientists in speculative science fiction and that people who are writing hard science fiction are thinking about, but it doesn't, I would argue, really percolate into kind of widely received science fiction, softer science fiction, until this. Until the beginnings of the human spaceflight program. This is John Glenn climbing into Friendship 7, in which he becomes the first American to orbit the Earth on February 20, 1962. And I would argue that in some ways the changes in popular science fiction dealing with time and distance really come to the fore after this. And it's the change of people really watching the distances and the time that it's required. So what's distinctive about Glenn's flight is the launch was publicized, the duration was publicized, and the landing was publicized. So people were very aware that this flight took just under 5 hours, 4 hours and 56 minutes to make 3 orbits of the Earth. It takes about 90 some minutes, and I point out the Toronto Daily Star here. It's their night edition, but if you can look at the text that their science editor has filed, it's filed as a story that was written in the midst of the flight. He is in orbit, present tense. This is what is happening. And one of the contrasts that you see between the Soviet Union tended to publicize their flights after they were completed. And when the American flights start and they're publicizing the launch, the duration, and the end, people, I think, are very intimately aware of just how long it takes. And this is the path of MA8, which is Wally Schirra's later Mercury flight, showing you 6 different orbits going around, so 90-odd minutes apiece to go around the Earth. So people become, I think, more intuitively aware of time and distance in spaceflight. And I would argue, kind of as audiences stop being quite so willing to accept Buck Rogers just showing up where he's supposed to be. And they want some answer in their fiction for how this happens. So what I'd like to do today for the rest of my time is to walk us through, we've talked about generation ships. We need to talk about faster than light drives. We need to talk about hyperdrives. We're going to talk about jump drives, and we're going to talk about wormholes. And I'm going to kind of run through these. We're going to run through these roughly in chronological order, but it means, so I'm going to start with what I would argue is a real revolution in the imaging of these kinds of things and the visual imagining by creative people of how you would solve these problems of time and distance. And that is the Star Trek Starship Enterprise. The museum actually holds, this is a picture of the model. It's the 11-foot studio model that was used to get those pictures in the original television series, which aired on NBC between 1966 and 1969. And what's remarkable about the Enterprise is it really was envisioned as a starship, not just a spaceship, planet hopping, but something that would be interstellar, that would move from place to place, that could cross the distances between stars. And and that therefore would kind of solve this problem that's out there in the popular imagination about what are you doing about time. Because, you know, without some sort of warp drive, right, all of season 2 is basically days at sea, in transit to the next place, right? So we need some way to solve that problem, and what they suggest is this very unique design that's very purpose-built. And I would even make the argument, if you when you came into the museum, you came past Lunar Module 2, which is a very unusual design for a spacecraft because it is in fact a pure spacecraft. It is a purpose-built craft that was never going to fly in 1G and was never going to fly in an atmosphere, and so it can have those weird gangly legs and there's no streamlining on it at all, and it can have that very unusual purpose-built form. In some ways, this contemporary ship of the imagination, the Enterprise, is similarly constructed for a very specific purpose, and that is warp drive. And so you're looking here at the back of the studio model that was used to get those shots. And we have an X-ray of the nacelle, which is the engine pod that runs in the back of it. And that really is the creative solution. So Walter Matt Jeffries, who was the art director for Star Trek, was also served in World War II, was an aviator, and had spent 4 years as a flight test engineer. So he brought what he called aircraft logic to the design of the Enterprise, which meant that as a creative artistic person, he thought about what the different parts would do. Right, so the Enterprise is not some flying saucer from the 1950s. It's not some undifferentiated pointy rocket that you can't figure out what the bits are. It has a crew compartment. It has a bridge, you know, where the command crew is, and it has these 2 cylindrical engines in the back that are this creative leap of saying we have warp engines that can do multiples of the speed of light, and that's going to allow us to conquer this problem of time and distance in spaceflight. And this is an idea that in some ways would make sense to people because they would be familiar with the speed of sound, and that you could, by this point, fly multiples of the speed of sound. So I'm showing you the Bell X-1 Glamorous Glennis that Chuck Yeager flew in 1947 and showed that the sound barrier was in fact an illusion, that you could measure it and pass it, that the speed of sound could be measured as Mach 1 and that you could fly Mach 1.1 or 1.2, that eventually by the late 1960s you could fly as fast as Mach 6. So we've got this idea then of the warp drive as something that does multiples of the speed of light, the same way that we had known by this point in aviation that you could do multiples of the speed of sound. Now the Star Wars franchise suggests all kinds of ships flying around with really no visible means of propulsion at all. And I'm a big Star Wars fan. And Star Wars does wonderful things with narrative and adventure. And Joseph Campbell and archetypes and the hero's journey, and if any, the exhibit about Star Wars that was here at the museum in the late 1990s still exists online, and it's a really rudimentary website because it was built years ago, but the content is still really good. So I will point you to that for your leisure viewing later. But the trick with Star Wars is what they do is they postulate a hyperdrive. Right, that you have some sort of a drive. So hyperspace is imagined in fiction as some sort of alternate dimension that you can kind of pop into, and it's essentially a shortcut through space. And you need some sort of a computer that will help you to navigate this alternate dimension that then pops you out at the other end in regular space, 3-dimensional, 4-dimensional space with time that we all exist in. And this is, in some ways, you can see there's a real focus on the storytelling and the adventure, and so hyperspace is essentially zooming stars and a computer that's bulky, that doesn't work when you need it to, or that's continually being, they're always fighting with the hyperdrive. But this is an alternate way of looking at this, and I would never talk down Star Wars, especially today of all days. But I will point you to Dr. Neil deGrasse Tyson did a great comparison between the Enterprise and the Millennium Falcon for National Geographic, and it's available online on their site and on YouTube, and you might have some fun taking a look at that afterward. Now, we've talked a little bit about generation ships, we've talked about warp drives, we've talked about hyperdrives. One of the other ways to work this problem of time and distance in space is to work it from the other end, not necessarily from the ship, but for the occupants. And so this is a shot from Alien, Ridley Scott's path-breaking film in 1979. It's a franchise that's still going. There's a new version of a new Alien-themed film coming out in 2017. But they suggest that you put the whole crew in stasis, some sort of a way that you kind of get around. You still have to go the immense distances. The ship isn't going to zoom in some way, but essentially it solves the problem of what we in spaceflight would say is consumables, right? Water, food, things like that. These people, you're not sitting around eating or drinking and just passing the time. You go into some sort of suspended animation and you awake at the other end kind of hungry and cranky. But you've gotten there, and so this is another way around this. You can work this from the technology side of the ship, or you can work this from the, what if we fix the humans? And stasis is one of the ways to do that. So Babylon 5, a show from the 1990s that aired on Warner Brothers Primetime Entertainment Network and TNT for 5 years from 1993 to 1998. If you haven't seen it, it's a show that very much is tailor-made for binge watching in an era that was ahead of binge watching, right? Because J. Michael Straczynski, who was the creator of this show, defined a 5-season arc before the show began. He wrote the Bible for the show. He thought about the characters, so he knew the beginning and the middle and the end of this story, and it meant that he knew where he was going. Every once in a while in science fiction, there's that feeling at the end of the episode that like they painted themselves in a corner and they didn't know what to do with it, and then they had to kind of back out and reset everybody so that they wouldn't have gone down some weird alternate road. Straczynski knew where he was going when he started, and so there's all kinds of foreshadowing in there and allusions to past things. People learn and grow. It's a show that really bears some binge watching. But it's also interesting because he had thought of an alternate way to get to hyperspace. So in Star Wars, you have a hyperdrive internal to the ship that gets you there. In Babylon 5, you have these external jump gates, they call them, that kind of float out in space and that create a stable vortex to hyperspace. And part of what's interesting in the world of these various warring alien races in the Babylon 5 universe is that these devices are become kind of sacrosanct, right? Nobody will, if you attack these, you not only cripple your own ability to travel, you not only cripple other people's ability to travel, you cripple your own ability to travel. So the jump gate is an interesting kind of external creative visualization of how you might create a vortex to hyperspace, and that would allow you then to jump around the universe. Now when we get to the reimagined Battlestar Galactica, which aired on the Sci-Fi Channel from 2004 to 2009, we have the confusion that they have these FTL drives, right? Faster than light drives, except they're not faster than light drives, they're not warp drives. We've talked about warp drives, multiples of the speed of light. These are jump drives. And in fact, what they're suggesting then is that you would have something that calculates the ability to literally jump from one place in space to another place in space. Did anyone have a chance to do the gravitational lensing discovery station, to look at the little ball that runs across? All right, so you're going to have a little leg up on this next bit of the discussion, right? So it's an old idea that basically, what if you could fold space-time, right? So Madeleine L'Engle in Wrinkle in Time in 1963 has it explained to the characters in there that if you, say, held out your skirt and you had a line, and you had an ant on one end of that line, the ant could walk across the fastest place between 2 points would be the line, if you stayed in that, so you would go straight across. But what if you could bring the skirt together? The ant moves straight from the first point to the second point. And the illustration in 2 dimensions that you saw of how light can get bent around a massive gravitational well, around a massive object, such that when you're seeing the light from a distant star, you might not see a pinprick, but you would in fact see a bit of a halo effect because the light had been bent around this star that's in between the observer and the star, is the beginnings in a kind of two-dimensional linear form of the idea that you could bend somehow space-time and this fictional dream that you could then jump from place to place. And that is what they're showing in the reimagined Battlestar Galactica. This is something that Isaac Asimov had suggested in his Foundation series novels beginning in the 1940s. But basically that it would allow ships to disappear in one place and reappear in another place. And again, they need time to spin up, so there's a kind of dramatic tension that the writers are able to use around what it's going to take to get people to move from place to place. And the final example that I want to show you can be well illustrated by Christopher Nolan's Interstellar from 2014, where he suggests that there is a wormhole, or essentially a vortex out near Jupiter that allows movement from place to place. So this is a similar idea in terms of the physics. We just talked about the tesseract, or the idea of being able to jump from place to place. The idea of a wormhole in space comes from the, if you were on the outside of an apple, you could either go around to where you wanted to go, or if there was a wormhole through, then you've got a shortcut. And there had always been this question of, like, what if you had some sort of stable vortex or stable black hole that would allow a kind of shortcut through space? And part of what's fascinating about this is that they worked with the theoretical physicist and astrophysicist Kip Thorne, who had done lots of math about what a black hole would look like. And then the interesting overlap between the creative arts people who are using computer programming to create the visual effects, that's equations, right? So he fed them his equations, and this is what they came up with. When they put that into the rendering engine for the computer-generated graphics, this is what they came up with, which is not anything that Kip Thorne had ever thought of. We've always kind of pictured a black hole as this like hole, right? It goes down, it goes down as a gravity well. And in fact, when they fed Kip Thorne's equations into the computer rendering, what they came up with is a kind of spherical rip in time that pulls all of the light around it and has that accretion disk that we see across the bottom. And part of what's fun about Nolan's story in Interstellar is he also uses time dilation. So Einstein and special and general relativity suggest the idea that a person traveling near a massive, huge gravitational field will experience time more slowly. And I won't, again, ruin the movie, but if you've seen it, they play with the idea of time moving differently depending on whether you're outside that frame of reference, whether you're in a stable place, or whether you are one of the ones traveling through this massive gravitational well. So I would argue that especially after the dawn of human spaceflight, and when general audiences started to become aware of the time that it took to cross distance, and in fact, when we talk about this kind of astrophysics, we start talking about space-time, right? These things are inextricable from each other, that people, creative people, have come up with various different ways of trying to deal with this in fiction. And it has been everything from generation ships to hyperdrives to warp drives, jump drives, and wormholes. And I hope that by showing you some of these examples of the ways that creative people have responded to this problem of time, that has inspired you and given you some new ideas. But right now, I'm out of time. Thank you.